Okay, safety. Thank your lucky stars you don't live in the UK. Oh my God, health and safety over there is crazy. You think we got it bad here? We don't. If you work at an industrial site of any kind over there, you have to have high vis and hard hats and all kinds of crazy stuff. But we have safety here because we want you to keep all your fingers, all your toes, not have any genetic defects created. Genetics you can't do, but you can cook yourself or somebody else if you do things wrong. Okay, now it's really hard to do that, but it can be done. So safety is pretty important. Plus you can fall off of things. So we're going to cover electrical safety, radio frequency exposure, and outdoor and mechanical safety. So electricals first. Don't get zapped. Everybody knows that, right? Don't be zapped. Avoid contact is the most effective way of practicing electrical safety. What's the easiest way to do that?
Turn it on. Unplug it.
Okay, turn it off. Unplug it better than turn it off. What happens if you turn it off and you turn your back and you're working on it?
Let me turn this one.
Somebody flips the switch on it, right?
We have this thing turn it off.
Well, we have this thing called lockout tagout that prevents that. Most modern radio equipment uses currents that are not as dangerous as older equipment, but they still can hurt you, so you still need to take precautions. And so that's why we emphasize the electrical safety. Install a master on-off switch for your station and your workbench. It could be as simple as a surge protector that has got the switch, you turn switch off. But I would suggest you also unplug it because the dog might step on it, it's on the floor, or you got kids or whatever. You don't want to be playing with anything that could possibly get turned on. It should be located away from the station and the workbench. Have it clearly labeled and train your family members and safety observers about the location and proper use of the switch. Be aware of your surroundings. Avoid placing yourself in harm's way. That's the biggest thing. Is look at it, don't just grab it, look at it, evaluate it, and then go do what you're going to do. Avoid locations or positions where there is a likelihood of exposure to shock hazard. Don't crawl up under your ham shack desk and be playing with high voltage stuff. Okay. Avoid hard to rescue locations and positions. So avoid those positions. Wash your hands after you use solder. It's on the test. Why would you wash your hands after you solder? Hey. Don't buy your solder for ham radios at Lowe's unless you take a really close look at the label, because they have taken the lead out of solder for a lot of things, because people were using lead solder for water pipes. That's not good. If you want lead in your solder for ham radio, it's the best stuff. Lead from solder on hands can contaminate food. If you wipe your mouth, whatever, you can get it in there. Turn off the power when you're working inside the equipment. Make sure the equipment is properly grounded and circuit protected. So yes, I think I get to those later. Don't use loose clothing while working on gear. If you're ever working in a wood shop or on a lathe, you shouldn't have long sleeves that are loose. Keep one hand in your pocket like this. That's called an Air Force glove. Why do you do that? Because if you have two hands, the electrical current can go across your chest, which is where your heart is. If you got one hand in there, it's going to go down that side, this side. You got a better chance.
How much current does it take to clamp?
We're going to cover that, but it doesn't take much.
Doesn't take a lot.
It's not a lot to kill you. It's not a lot to put your heart in arrhythmia, to mess up your heartbeat. So, where was that?
I say you'd rather get hit with a hard jolt than a soft, real light jolt. Because a hard jolt will collapse your heart and you start beating again.
And a hard jolt will typically throw you off of it.
Mitigating electrical hazards. Don't work on live circuits unless absolutely necessary. Sometimes you have to have power on to test the circuit. But in today's age, the circuits are so tiny that the odds of you working on them are so close to nil, it's zero, statistically. If you must work on live equipment, always have a second person present to act as a safety observer and make sure to know what to do. Where's that master switch? Not to grab onto you to try and pull you off. Wear shoes with insulated soles. And remove all of your jewelry, okay? Don't have any jewelry on. A DC voltmeter will read the average voltage, which on an AC circuit is 0. This is a multimeter. It'll test ohms, amps, and resistance. And if I put this on DC and I stick it into the outlets over here, it will read 0. You know there's 110 volts with a 15 amp circuit breaker. That can kill you. But it'll say 0 and you'll think it's okay. Make sure you've got the right setting on it. So, if you're squeezy, this next slide is accident pictures. And they're not horrible, but if you're queasy, close your eyes. That's what happens when you wear metal jewelry around electrical equipment. Somebody didn't want to take off their wedding ring, and that's what they did to themselves. Now, we had a guy in automotive mechanics, okay? DC voltage. You're not supposed to wear your dog tags. Well, you're in the military, you wear your dog tags, right? We're not supposed to wear our dog tags when we're doing maintenance. Because you can get hung up on something and everybody's like, that little chain will break. Nah, it doesn't have to break. This guy leaned over a battery, his dog tags fell out, and they went across the post of the battery. Well, it's a direct short from one terminal to the other, right? So the current won't go around your neck
Until it changes.
for about that long, until that chain goes poof. And then it went around his neck, and he has a scar for the rest of his life, all the way around his neck, where he has that little beaded chain. Take your jewelry off, it's not worth that. That is bad. Okay, when working inside equipment, insulate or otherwise secure all loose wires. You don't want that one loose wire over, I'm just going to move it out of the way. It's hot, but it's not going to touch anything. Because you're going to drop something on it or bump it or something, and it's going to do bad things. Use a bleeder resistor or grounding stick to make certain that capacitors are discharged. So that doesn't show up real well up there. But that's a little stick with an insulated handle and a little hook on the end and a ground strap, that little red thing on the bottom, the ground strap. And you discharge the capacitors with that. If power is required, avoid unintentional touching of circuitry. It usually is unintentional when you get zapped. So avoid that. Never bypass safety interlocks. So they're there for a reason. I need to work on it, but when the case is open, it shuts off the power. Well, let me just jimmy that switch there. I'll make it vicious for you. Don't do that. That's where you get hurt. Capacitors, that big blue thing is a capacitor. There's smaller ones, there's bigger ones. They're basically a big battery that's ready to discharge everything in it in a flash. Don't let the flash be your finger. So that is on, it's yellow, so it's on the test. Storage batteries are dangerous when shorted. We just talked about that, what can happen. So both that's on the test as well.
They can blow up.
They can blow up as well, yes. So they have multiple. They can catch fire. Lithium batteries can catch fire. They'll really catch fire if you throw them in fire. They'll really catch fire if they're in a flood and they're called an electric vehicle. Don't overload single outlet.
You're gonna have fun with this.
Okay, so this thing in the wall has got 2 outlets. You're allowed to have a certain number of fixtures. I don't know how many it is, but there's a certain amount. And the total is how much that circuit breaker and circuit or fuse in your main panel will allow. Okay, so when you start plugging in an electric heater in the top one and an electric heater in the bottom one, you've already exceeded the capacity of that circuit. And there's a whole bunch more plugs you can use, right? But we don't have enough plugs today, so what do they sell us? For $1.99, they'll let me put 4 in there. Or 6, or a power strip with 10 or 12 or whatever. And one of them, and you still got another one open. And winter time comes around, you plug a heater in there, and the next thing you know, you got fire. So don't use those. These, they're handy when you're out working in a shop, but realize that the 110 volts, 15 amp circuit, you can't plug 3 heaters in. You can't plug 2 heaters in. Don't overload single outlets. So, there you go. Don't do that. If you know what you're doing, that probably could be safe, but I see a big extension cord. On the end of that extension cord is probably a sugar tap. And he's probably trying to run something. And then he's got some other stuff. And he's got one there he can't fit in. Well, this guy's got 6 plugs into one outlet, one double outlet, okay? Unfortunately, he's still only an amateur. Not an amateur radio operator, he's an amateur electrician. This guy Has 9 of them.
Yeah, typically, you'll see this in an old house that
Yeah.
doesn't have enough outlets, right? And they don't have enough outlets because they don't have enough circuits back in their,
Because they didn't have all
the
this
breaker box. So you need to pay attention to what you're plugging in and don't exceed either the 15 amp or 20 amp or whatever that circuit load is.
Okay, so don't do that. But this guy is still only an apprentice. But this guy,
There's a
Like
pro.
my house.
he's got 10 of them. And he's a journeyman. He's still not the top of the line. The winner is 14. And that's this guy. 14 Christmas tree light screens into one $9.99 special from Walmart, guaranteed to not protect anything. And I have actually gone into a home that I had that was empty down in California. I went down there to work on the house after we had a change of tenants, and one of those was plugged in. And we walk in the door, and we smelled fucking burning stuff. And we went and we found that was melted into the carpet. It started fire, but it was melted into the carpet. Yeah, don't do that. And why do you think we have so many Christmas tree fires or house fires around Christmas? Don't do this. They're light draws, but there's so many wires that could go wrong. And that's probably what literally a $9.99 Walmart special power strip. Spend some money on power strips. UL listings. Buy UL listing stuff. Make sure your home is up to code. That'll help. Most town equipment does not require special wiring or circuits. Use 3-wire power cords. 3 wires, not 2. Connect all AC power equipment to a common safety ground. That's that 3rd prong. Install mechanical interlocks in high voltage circuits so that when you open the cupboard or the cabinet or the lid, it shuts it off. Fuses and circuit breakers remove power in case of an overload. On a 120 volt AC circuit, the fuse or circuit breaker should be in series with the hot conductor only. Now, we have a color code. In AC, black is hot. In DC, black is brown. Let's see, who's the idiot that came up with that? So,
Please note the amount of yellow text in
Yes.
this slide.
the ones that screw in are really cool because if you run out of fuses on a holiday weekend, you can't get to a store because they're all closed. And you can just stick,
Any for really.
You can just stick a penny in there, right? Yeah. And don't let your insurance go, because your house is going to burn down. 120 volt AC circuit, only the hot conductor. They don't care about, they're not going to ask what color, I don't think, on any of the questions.
Yeah.
Only the hot conductor. And fuses and circuit breakers remove power in case of an overload. Use circuit breakers, circuit breaker outlets, or ground fault circuit interrupter, or GFCIs. Use proper fuse or circuit breaker size. So if the fuse keeps popping, what do? You got a 20 amp, what do? Stick in a 30, right? No. Find what's wrong. Find what's wrong. That's the problem. Never replace a 5 amp fuse with a 20 amp fuse, or excessive current in that circuit could cause a fire, and that's yellow again. And the reason that is the fuse won't burn before the wire does. Okay, that's what fuses do. They protect the wire from getting overheated and burning through it and burning up, starting a fire or melting in two. So when you're running the DC power supply to your radio inside your car, don't get that little skinny speaker wire because it's easier to hide in the fascias and stuff of your car. Get the big fat stuff that will carry the power that you need. Okay, responding to an electrical injury. So this is, you're not the injury, somebody else is, I'll leave it. Shut off the power. Ensure the on-off switches and circuit breakers are clearly marked so the responders can power the system down. Call for help. The National Safety Council estimates there are 300 people die in the United States each year from electric shocks on 120 or 240 volt circuits. 300 people a year. A 50 volt AC electric shock. So 50 volts. We got 110 to 120, call it 110, 120 in the wall. So half of that for as little as 1 second can disrupt the heart's rhythm, causing death in a matter of minutes. That's all it takes. As little as 30 volts can cause a dangerous electrical shock. So our radios are generally 12 volts, right? So we're good, right? But there's circuits in there that jack things up. So there's more than 12 volts in the radios. But there's no yellow there. Electrical safety. Don't be this guy. The body becomes part of an electrical path, and you've got a broken, see the broken terminal that says that's not broken. Somebody had a 2-prong outlet in their house, and it wouldn't fit, so they took the side cutters off and cut that off, is most likely what happened. Took that off. There are adapters, but the adapters don't do you any good either, unless you actually have a ground available in the box, and you actually take the screw out of the faceplate and put it, shaking head over there. But they'll make it fit, but it's not safe. So what he's done here is he's got a metal bodied tool, so he has become the ground and the power is going through him. And you don't want to be that guy. Never assume equipment is off, the circuits will be energized. They sell little non-contact testers that will tell you the voltage. Don't trust them 100%. Because test equipment can fail. But if you put it over there and it goes, wah, oh, that's hot. I should de-energize that. Charges are stored in capacitors. I think that's the third time we brought that up, isn't it? So charges are stored in capacitors. Don't be the system that creates the short discharges. Check with a meter first. Never mount an antenna on a power pole. The antenna could contact high voltage power lines. I'm not too worried about the antenna contacting it unless I'm holding it. I'm more concerned about you or me contacting the power line while we're being stupid enough to climb up the power pole trying to put the antenna up there. Okay. Never mount an antenna on a power pole. It's yellow. The antenna could contact high voltage power lines. You think your toaster burns stuff? Try that big old power line. Okay, electrical injuries still. Shocks, burns, even small currents can cause problems. High voltages can penetrate the skin, greatly reducing resistance. So the high voltage can get through your skin. And what's below
Next issue.
What's below your skin? Blood, right? The body is 98% liquid. So now it's got into your system and there's a high saline content, so it's a great electrolyte, so the power can just go right through you. Current flowing through the body does damage by heating tissue, disrupting electrical function of cells, and causing involuntary muscle contraction. Okay, electrical injuries, there's the threshold, 1 to 5 milliamps. That's 1,000th of an amp. So 1 to 5 thousandths of 1 amp, you get a tingling sensation. Pain is 5 to 8 thousandths of an amp. Intense or painful sensation. You can't let go at 8 to 20 milliamps, thousandths of a volt. That's thousandths of a volt.
Amp.
Amp. And there's up to 15 amps in that plug. So, yeah. Yes, milliamps. All these are milliamps. Amount of current flow. Paralysis is anything greater than 20 thousandths of an amp. Respiratory paralysis and pain. Fibrillation, that's your heart, 75 to 1,000 milliamps. So 1,000 milliamps is 1 amp. And there's 15 of them in that wall. Defibrillation is greater than 1,000 milliamps for creates sustained myocardial contraction and possible tissue errors. Notice that there's nothing up there that's yellow, but fibrillation and defibrillation, those are bad. And it's way less than what's in the wall out there. Fibrillation level, function of current over time. So how much current there is and how long you're on it. 500 milliamps over 0.2 seconds will put you in fibrillation. 75 milliamps over half a second, so a whole lot less, is fibrillation. Immediate unconsciousness at the 75 milliamps for a half second. Again, have a safety observer who knows CPR. When you have a safety observer, make sure, because I had a safety observer, I was running a chainsaw. And I had my father-in-law out there. He was my safety observer, and he couldn't help with the wood or anything, so he was just going to sit there and watch. And like, be done. what are you gonna do if I get hurt? And I've been working for hours. What are you gonna do if I do get hurt? He said, call 911. I'm like, okay, great, awesome. Where are we? Your house. Where's my house? Sam's house? Okay, where did Sam die?
You had my address.
He had no clue what my address was. He just knew how to get to my house. He didn't know what road I was on. It's like, make sure they know how to get the emergency responders to you. It's a little better this day and age. They can probably track your cell phone. Actually, if he's using his phone, it's going to give him his address. They'll be sending him to his house. Keep that in mind. Wiring and safety grounding. It's on the test. The National Electrical Code, or NEC, covers electrical safety in the ham shaft. That's because it's typically a building in your house. Okay, if you're smart, your ham shaft is in a sliding camper so you can bug out, but we don't all have that capability. So if it's in a building and it's got a system wired to the grid, it's the NEC. Local electrical codes establish tower and antenna grounding requirements. Okay, so if you want to put a tower up, you need to ground it. Local codes cover the tower and antenna grounding, and the NEC is your shaft. Wire size, so 15, and here we go again. Keep
And you will have one of these two on your test.
One of those will be, odds are. 15 amp circuit is a number 14 AWG. That's American wire gauge. And a 20 amp circuit requires number 12 AWGs. Okay? Now, if you're buying wire, this isn't on the test. If you're buying wire and you want on Amazon, pay close attention. They will sell you 15 gauge wire, or 12 gauge wire, or 14 gauge wire. That's not AWG. That's smaller. And what generally they do is it comes from China, and it's aluminum, and it's a thin, skinny wire with a big, fat, cheap insulator on it to make it look the same size, and it's not as good. So pay attention to whether it's actually AWG. And when you're buying things like Zipline, which is a black and red together for running your radio circuits, go down to those reviews and look for the ham radio operator that's down there and saying something. 30 amp circuit requires 10. Distance is also a consideration. Check the published charts. I'm building a bus. If I run 12 volts from the back of my bus to the front of my bus, I don't have 12 volts at the front of my bus because voltage drops. But I'm going to run a 48 volt main line and then pull off of that with a converter to 12 volts, and I'll have 12 volts at every one of those fuse blocks at that, where it comes out of there. And that's to reduce my electrical usage and keep my voltage up, because 12 in isn't 12 out 100 feet away. It's probably, what, 5 at 100 feet? Okay, AC color codes. Here's what I was alluding to earlier. On AC, alternating current, because I don't know if we described that before. AC, the black or red is hot on AC. It could be the black wire. The brass-colored terminal or screw on these outlets, there's brass on one side and silver on the other side, and that's telling you that the brass terminal or screw gets the hot and the neutral gets the silver. Okay, so just take silver. The colored one is black or red, the brass colored one. If you are installing it, do it right. If you're going in your own house and you're working on it, make sure the guy that put it was in there last did it right. I found green wires with 110 volts on it. AC color codes: green or uninsulated bare copper wire is the ground. Green colored or bare copper terminal screw. So if you look on that outlet, there's a green screw on one end of it. That's where you put your ground in. Always connected to the chassis or the box. If you've got a metal box and screw it into it, that's connecting it to the chassis. If you have electrical conduit and all the joints are correct, and this, that, and the other, you want the wire. You want the wire on the green one. AC, since you're an electrician, if I say something wrong, let me know, and I'll fix the signs.
We don't have time.
Oh! Okay, wiring and safety grounding, AC color codes. So there's your little upside down. I always thought, but in the last class, somebody said, no, that's the correct way. So you're the electrician. Is there a legit correct way, or does it matter?
We call that the Eastern.
Easter.
eastern border or coast, east
Okay.
coast.
Yep.
That's the east coast way. We do it the west coast way.
Okay,
We
so
make
is that-
happy faces.
So is that a code thing, or the
It is.
central thing yet, or?
You can put that receptacle in any angle.
Okay,
Any
and
configuration you
then,
want.
and
You
then,
can lay it horizontally, you can
Okay.
flip it to the right,
Okay.
left, it doesn't matter.
okay, because I have seen them that way, and both sides of the country.
Well, the only thing is if you have objects on a metallic wall,
Uh-huh.
then you want to put it in this way, because it'll hit the ground,
Ah,
the equipment ground before it hits the eyes.
okay.
That's.
Well, isn't the spark that what tells you that it slid off the wall?
No, sometimes it's the ouch when you get shocked.
Okay, okay, so,
Save you a headache.
you see the little, can you tell the difference between those two vertical slots that, you know, one of them's got the green circle around it? Can you tell that one's a lot taller than the other one? Okay, that little one, the short one, is the black wire or hot. And the long one, the taller one, is the white wire or the neutral, not ground, neutral. And then that third prong is green or bare, and it is the ground, okay? DC color code, so we just covered AC, right, where the black is hot, right? Could be red, but black or red is hot. DC, red is hot, black is ground. So you should know what circuit you're working on, that's the point here, okay? Make sure you know whether it's AC or DC. So there you go, there's a couple of power cords. What do they call this other one on the left?
That's a barrel connector.
This polarized barrel connector. And then the one on the right is an SAE that plugs in, which is standard automotive engineers, and the cigar lighter plug. So that's an SAE two-prong. They're pretty durable. I like them, but everybody in ham radio seems to be going to a thing called Anderson power poles.
I don't trust Anderson.
I don't like them, I don't trust them, but they're getting really universal. So they work, but
They're quick and they're easy.
and they're
to
cheaper than those
use.
SAEs. But
Yeah, but I'll stay with SAE.
I'm not confident in them, but if you want to get involved in the stuff like Steve's doing and Crystal and with the CERT, they're probably all running Anderson power poles, and so when you show up and you need power for your radio, you're going to need at least an adapter from an SAE to a power pole, or have all your stuff on power pole. Okay, protective components. Okay, we've got, they prevent equipment damage, they prevent safety hazards. We call them fuses and circuit breakers. There's fast acting and there's time delay or slow blow that we call them. All right, and so we've got an assortment of them up there. From left to right on the bottom one, we've got it's not an ATC. I don't know. We call them bus fuses.
ACG.
The next one from the left is your standard automotive fuse.
Automotive blade connector.
Blade fuse. They have those are ATC, and there's some other designations. But they also now have mini ones, and there are maxi fuses.
Bruce, I have a question.
Yes, ma'am.
Why do you prefer a fast acting to a time delay? Is there what's the,
We used to use time delay on some of the equipment on board ship because there would be an instantaneous surge that you wanted to get past.
Yeah.
So it was a delay system that would allow us to get past that first surge, and then it would protect the circuit.
So the three on the right, you're going to find those on the bottom one. You're going to find those in like test equipment. They're little tiny short ones. You might find them in some radios and stuff like that. But the standard one is the two on the left, or a version of them. On the right hand side, the older houses have the screw in ones. I don't know how many of those I've ever taken out that had a penny underneath of them. Scary.
Yeah.
And then another glass fuse there, and then of course a circuit breaker that we should all be familiar with, but unless you've opened up an electrical panel, you may not. All right. Always include a fuse in home-built 120 volt and 240 volt equipment. I believe that is a keyboard for sending Morse code. I'm not positive, but I believe so. Steve?
Yeah, looks like it, yeah.
So you can send Morse code and you don't have to know. You just type it.
If you know how to type.
Well, you got two fingers and two eyeballs, right? At least one eyeball and one finger, right? You can type. You can probably with one eyeball and one finger type a whole lot faster than I can send Morse code. Fuses. Ground fault circuit interrupter, I passed one around earlier. GFCI, there's 3 different versions of it. So I believe that 2 on the right are, well, the one on the left is just to replace an outlet. Okay, and then you can have all the outlets that are downstream of that, or electrically downstream, can be protected by that one outlet. Okay, so you put the first one in the circuit is one of those that protects everything downstream. The ones on the right, those are circuit breakers, they're ground fault or arc fault. So what sets these off, a spark sets off the arc fault. The GFCI, if the voltage, voltage current through the 2 sides, the neutral and the hot, doesn't match within a very, very tiny specification, it goes, something's not right, and it blows. Okay, the GFCI disconnects power currents in the voltage carrying the hot wires.
Disconnects power if currents in voltage carrying wires. There's the key phrase.
Cause is current flowing to ground. Okay, that's the cause of it, and you want that to happen, you want that to work. It's really nice to have GFCIs in most places, but if you're trying out in the shop, don't have a GFCI and a 110 volt welder. Power supply safety interlock. It opens the circuit if an enclosure is open. It shorts the high voltage to ground if the enclosure is open. Ground on metal enclosure prevents voltages from appearing on the chassis. So what that means is the ground wire from that 3rd prong should be connected to the metal chassis on the outside that you're going to touch. That's your safety feature. So that if something shorts inside and puts juice to the enclosure, it's grounded, and it should blow your fuses or circuit breakers, but it's not going to go through you. It's going to take that easier path to ground, and hopefully you're not the easier path than the wire that's going out there. All metal enclosures of station equipment should be grounded to ensure that hazardous voltages cannot appear on the chassis. Now, somewhere down the road, we're going to mention that they shouldn't all be daisy linked together, daisy chain. So your radio and your antenna transmatch, and the other radio and your power supply, and you shouldn't have them all connected in one wire going to the ground. You should have the ground come up to a bus bar that is the ground, and each individual one has its own ground wire going to that big bus bar.
Individual paths to ground. It's
Yeah.
a safety feature.
That's what we teach you. In the real world, I don't know
Real
how
world,
many
different
people do
story.
that. Some do, some don't.
So I just take a copper clad plumber's strap and go right across the back of my desk. That goes to ground, and every piece of equipment goes to that plumber's strap. That's a good conductor, right? And being 1 inch wide, you get a low impedance, so it's a good RF ground as well as a good DC ground. And I just run that right across the back of my Ham Shack desk, and every piece of equipment gets clipped right to that.
Do we got that now?
Yep.
We're good. Battery safety. Okay, batteries can hurt you. Storage batteries, this is red, not yellow. Storage batteries, particularly battery banks, can contain hundreds of amps of power, corrosive acids, explosive gases, and other hazards. And so we probably ought to update that, because lithium will burn and burn and burn and burn, and you can't put it out.
Right.
If you have a fire extinguisher, you have one purpose. And most fire extinguishers only have one purpose, and that's to cool it down long enough for you to get out. They can also blow up. Lead acid batteries create hydrogen gas when they're charging and discharging. So, shorting battery terminals, yellow, can cause burns, fire, or an explosion. That's the hydrogen generally in a lead acid battery. Charging battery too quickly can result in overheating or outgassing. If you're charging a lead acid battery, it is outgassing, period. It's part of the chemical reaction of charging it.
Can't help it.